Hello, good people, and welcome once more to Work and Philanthropy Foundation TV. At Workfood TV, we simplify, we demystify, and we exemplify elementary mathematics for your understanding. This will help you convey this knowledge to young ones or to use it in solving basic problems in mathematics. Before we go on with our lesson today, we want to call on you to join us in our initiative to assist underprivileged learners in local communities. These people need your help in one way or the other, and we believe together we can support them in their education to make them great people tomorrow. At the end of the lesson, we are going to provide you with a link where you can find the full project explained, and of course, you will identify in which way you can be of help so that together we can assist these children. That said, last time we talked about cuboid and we handled the different aspects of a cuboid. That is the height, the length, the width, and of course the volume of a cuboid. We promised you that this time around we're going to look at pyramids, but for some reasons we are going to look at cylinders. And in today's lesson, we have 4 targets, and these are, by the end of the lesson, we should be able to calculate the curved surface of a cylinder. We should be able to also calculate the area of a cylinder closed on one end. As well, we should be able to calculate the area of a cylinder closed on both ends. And lastly, we should be able to find the volume of a cylinder, or better still, to find the volume of water or liquid that a cylindrical container can hold. Without waste of time, we are going to look at some key facts about a cylinder. Then we're going to handle each of the aspects carefully so that you can better understand with practical examples. The first thing that we should take note as far as cylinders are concerned is that a cylinder has a circular cross section. Circular cross section in this case is the bottom and the top. If you look at it carefully, you realize that it is circular. And if it is circular, then we can begin to think about the radius, we can begin to think about the diameter, we can begin to think about pi. So take note of this, as it is going to be very helpful as we move along in this lesson. The next very important aspect of a cylinder is that a cylinder has a curved surface. If you look at this diagram, the surface is curved. It is not plain as in a rectangle, a triangle, and the rest. So this cylinder has a curved surface. And the last thing to take note of is that if you cut this cylinder and open, it is going to give you a rectangular shape. Take note of this because this is one of the ways in which we demystify elementary mathematics. Here you find a shape with a circular end, you find it with a curved surface, but if you cut it open, it's going to give you a rectangle. So take note of this aspect as we move along with this lesson. With this said, let's go into the first aspect, which is how to find the area of a cylinder open on both ends. Now, let's look at this and think carefully. If a cylinder is open at both ends, we should be thinking of objects which have this kind of characteristic. For example, a pipe. A pipe is open on both ends and has only the curved surface. So if we talk about finding the area, the surface area of the curved surface of a cylinder that is open on both ends, we are talking about the curved surface only. So let's look at this together and which rule we can use to find the area of the curved surface. Here is our first aspect, and it says surface area of a cylinder opened on both ends. So how do we find the area of the curved surface only? The rule is simple. It says curved surface is equal to circumference times height, and this circumference is circumference of the cross section, circumference of the base times the height. If you multiply this, you're going to find surface area of the curved surface. Let's look at this practical example and apply this rule to see how we can solve it. Here is a practical example What is the surface area of a pipe whose radius is 14 centimeters and height is 20 centimeters? Now let's identify what has been given and what we need as far as the role is concerned, and substitute the letters with the figures and simplify where necessary to come out with the answer. So in this case, we need pi, which is equal to 22/7. We can also say pi is 3.14. We also need radius, and radius is given as 14 centimeters, and we need the height, and height here is equal to 20 centimeters. Therefore, curved surface area will be equal to 2 pi radius height. And if we want to substitute here, it will be 2/1 times pi, which is 22/7, times radius is 14/1, times height is 20/1. 7 here, 1 time, 7 into 14, 2 times. 2 times 22 is 44. 44 times 2 is 88, and 88 times 20 will give us a total of 1,760 centimeters square. Do not forget your units, because this is area, and so the unit should be square. So this is what you are supposed to do to find the curved surface area of a cylinder. Now let's move on to the second aspect. B, surface area of cylinder closed on one end. In other words, surface area of cylinder opened on one end. All is the same, so don't get confused. Now the rule says area of curved surface plus area of cross section. This is very simple to understand. Here, if you have this closed on one end, maybe at the top or at the bottom, and you're asked to calculate the surface area, you are simply supposed to find area of curved surface, which is what we've done here, and you find the area of the closed end. If it is the bottom, it is circular, so you find the area of that circular bottom and add to the area of the curved surface. If it is the top, it is also circular, you find the area of that circular top and add to the curved surface. And that is what this rule here explains. Area of curved surface, which is 2 pi radius height, plus area of cross section, and the cross section is a circle, so it is pi radius square. Now let's apply this rule practically in an example to see how this is done. Calculate the area of a bucket which is 15 centimeters tall and has a diameter of 14 centimeters. You have to picture in your mind, what is a bucket? A bucket is called a bucket because it is open on one end and closed at the other end. So this is a cylinder which is closed on one end, and therefore this is the rule we are going to apply in this question to solve. But there is another trick here. Instead of mentioning the radius, they've mentioned the diameter. And with our knowledge of circles, we know that if the diameter is given, we can use this diameter to calculate the radius. So let us first of all, identify all we need, and then we move to simplify where necessary. Pi is 22/7. That is 1. We need radius. Radius here we don't know, but we know the diameter. So radius will be diameter divided by 2. And diameter is 14 divided by 2 will give us 7 centimeters. So our radius is 7 centimeters. And the last thing we have to identify is the height. And the height in this case is how tall the bucket is, which is 15 centimeters. Therefore, surface area in this case will be equal to 2 pi radius height plus pi radius square. Now we substitute. So this will be 2/1 times pi, which is 22/7, times radius. Our radius is 7. So radius here will be 7/1 times height, which is 15/1. All this in brackets, plus pi, again 22/7, times radius 7/1, times radius again, because it's radius squared, 7/1. This 7 can simplify this 7 can simplify this. 2 times 22 is 44, and 44 times 15 will give us a total of 660 centimeters, plus 22 times 7 will give us 154 plus 660 will give us a total of 814 centimeters square. This will be the area of a cylinder closed on one end, that is a bucket, as in this case. This is what we had for you today, and we believe you've learned something great. If you did, consider giving us a thumbs up. Share your thoughts in the comment section so that we can improve on the service. Don't forget to link up with us in the project for this year. Follow the link in the description for this project, as well as do well to contact us so that together we can assist some of the underprivileged learners in local communities. We look forward to seeing you in our next lesson. Don't miss this lesson. Until then, it is goodbye from us.